Okay. So here wave is propagating in the z direction, and they asked us to calculate the power flow through the surface of 10 meters square, which is available at z is equal to 10. So z is equal to 10 means it is parallel to, this is very, very important point. See carefully. This is parallel to xy plane. Z is equal to constant. Z is equal to 0 means xy plane. Z is equal to constant means plane parallel to xy plane at the distance of 10 meters. So Z is equal to 10 is parallel to xy plane. Parallel to xy plane means its direction is z cap only. This is what you need to understand. This is as simply z is equal to constant. If you have any differential surface, it is framed due to the changes in x, changes in y, but direction is given by z cap. Okay, parallel to xy plane means because of the changes in x, because of the changes in y, that particular plane has been created. You can assume like this. Here x is changing, y is changing. So x is changing, y is changing. So this particular surface has been created. But its direction is always, the surface direction is perpendicular to the surface. That means z cap on. Okay, so this is the point you have to remember. Now, what is the main thing means power is propagating in the z direction. That means our p bar is available in the z cap direction. Surface also available in the z cap only. So dot product between z cap and z cap will be the maximum power flow, because the dot product between the two same vectors are the between the vectors which are of the same direction means angle is 0, cos of that angle is 1. That means maximum power flow will get. So this is the identification you have to perform in your problem calculation. Whether we are calculating the power flow, uh, whether we are calculating the power flow in between the two vectors, those two vectors are of the same direction or not. You need to concentrate on p bar direction. You need to concentrate on the surface direction. If these two are the same direction, simply the product is enough. Okay, the product is enough. You can do the integration over. You will get the result. But when you have the situation like this, power is propagating in the z direction, but if they have given the plane is like this, plane if it is like this, its direction is like this, plane direction is like this, that means the s bar direction is available in this particular direction, but power is propagating in this particular direction. At this moment, surely you need to concentrate on the directions of these two. Simply if you multiply the area with the power, you will not get the power density, you will not get the answer, correct answer. Okay, that is the importance of this particular dot product. Everywhere we are telling the importance of the dot product. Okay, starting from our work concept. Okay, force into displacement. Dot is very, very important. So in which direction this power is propagating? In that direction only your surface direction is also available. Then maximum power flow will be available. Okay, because cos 0 is equal to 1. But if it is in the some other direction, you will not get a maximum power flow. Okay, surface is like this, but power is in a different map. If the power is propagating like this, surface direction is this one, power is propagating this one. So this particular surface cannot able to catch the maximum amount of power. Okay, this is the concept you have to take care. So ds bar is equal to some ds into n cap. So direction of this particular surface you have to carefully calculate. Okay, now we'll see one problem based on this one. You can write while class is going on, you can write the things. Now the problem is in a non-magnetic medium. They have mentioned non-magnetic. This point already I have told. When they have told non-magnetic, simply you can take mu r is equal to 1. Next, they have given E bar in this particular problem. E bar is equal to 4 sine of 2 pi into 10 power 70 minus 0.8 x z cap volts per meter. Okay, this is what they have given. What we need to calculate means here 3 bits are there actually. Okay, first question is calculate epsilon r and eta. Next, B is time average power carried by the wave. Okay, time average power carried by the wave. And the third one is the total power crossing 100 centimeter square. 100 centimeter square of plane 2x plus y is equal to 5. So whatever the concept I have told, all those things we have to apply here. So first of all, from the given E bar expression, what we can take? General E bar will be like this. E bar is equal to E naught into E power minus alpha z into sin r cos. We can take sine of omega t minus beta z. And okay, here they have given x, so I will also take x only without any confusion. So I'm taking here beta x and the direction is orientation is z cap. Okay. Now by comparing these two, we can tell E naught is equal to 4 and there is no e power minus alpha z term in the given expression. So alpha is equal to 0 and omega is equal to 2 pi into 10 power 7 and beta is equal to 0.8. Direction of propagation is x and E bar is oriented in z cap direction. So all these things we can able to take from the given single expression only. Now omega by beta here actually in order to solve the power we need the problems we have the equations like this. P average is equal to what is the formula 1 by 2 real part of E bar cross H bar conjugate. But as they have given E bar, we can convert this formula into only E bar terms. So E by H or magnitude is equal to eta. So H can be written as E by H. That means E will come 2 times E square by eta. So this is the formula we are going to use for the calculation of the power density. Okay. But here eta is not available. So to get eta, what we need? Eta is equal to square root of j omega mu by, they did not talk about conductivity. So you can take 0, j omega epsilon plus sigma is there. I'm taking it is 0. So it is equal to, now we can write mu by epsilon, but mu means mu naught into mu r by epsilon naught into epsilon r. Here they have given mu r is equal to 1 because it is a non-magnetic medium, but we don't have idea about epsilon r. So epsilon r is required to be calculated. For that, you calculate here using omega and beta, you calculate the phase velocity omega by beta. So what is that one? 2 pi into 10 power 7 by 0.8. Okay, so this is equal to, you write in meters per second, it will come in meters per second only. So your velocity is equal to, you tell the velocity, calculate and tell the velocity, how much you are getting. Pi by 4 into 10 power 8. Did you calculate pi by 4? This is 8 by 10, 10 will go outside. So 2 ones are 2 fours are. So pi by 4 into 10 power 8 meters per second. This is the velocity of the this particular wave. Okay. Then velocity is equal to, we have another formula that is square root of 1 by square root of mu epsilon. So this is equal to, we can write now square root of mu naught mu r epsilon r is equal to pi by 4 into 10 power 8. We can equate like this. It is equal to 1 by root of mu naught epsilon naught will give 3 into 10 power 8. And mu r value is 1. But here we don't know the value of epsilon r. We will keep like that only. It is equal to pi by 4 into 10 power 8. So here unknown thing is epsilon r only. So you can calculate epsilon r from this one. How much you are getting epsilon r value? 14 point something will get. 14.59 will get as the epsilon r. And we don't have units for epsilon r. You keep like this one. Now you have epsilon r value. As I said, we can get a eta value from this one. Okay, so eta is equal to root of mu naught by epsilon naught value is 125. So mu r value is 1 by, okay, 1 by epsilon r value is 14.59. This root of mu naught by epsilon naught is nothing but we can take 125. So you can calculate like this eta value. So you calculate and tell the eta value, how much you are getting. Anyone can tell. 98.7 ohms. You need to write notes. Okay, simply don't listen. Just parallel you can write the notes. So eta value we got. Okay. When we get the eta value, we can start calculating the power density. Okay. So the average power density is equal to 1 by 2 real part of E bar cross H bar. It is equal to, we change it now because they have given E bar here. So real part of H is equal to, we can write E by H. So E square by eta, that is equal to 1 by 2. What is E? What did we get? What they have given E value, peak value is 4. So 4 into 4 by eta value we get 98.7. 98.7. So this average power density is equal to something you'll get, that is 81. Okay, you may get 81. And what is the direction of this particular average power density? 81 milliwatts per meter square. But what is the direction? It is a vector. What is the direction of the wave? That is the direction of the power. Remember that. Direction of propagation of wave is equal to direction of power density or power. Direction of propagation of wave is equal to direction of power. So they have given beta x, I think. Yep. So 0.8x means it is in the x cap direction. Okay, this is the thing. Now we are required to calculate average power. Okay, passing through 100 centimeter square area on the plane 2x plus y is equal to 5. Okay, this is the plane. On this plane, this is actually infinite length plane. Infinite plane. But we no need to consider the total plane. On this plane, only 100 centimeters square we have to calculate. One thing you remember, we got here power density in milliwatts per meter square. So units must be same. But they have given here 100 centimeters square. So 1 centimeter I'm writing as 10 power minus 2 meter. Another centimeter 10 power minus 2 meter. So that meter square. So first of all, I converted this area into meter square. So no problem. This one will be cancelled. So 10 power minus 2 meter square. This is a surface area. Okay, in magnitude wise. But what is the direction? I have given from our module 1 onwards, if the surface is ax plus by plus cz is equal to some constant, surface is having the unit vector, that is a normal direction, normally directed unit vector is given by a x cap plus b y cap plus c z cap by square root of a square plus b square plus c square. Okay, this one we have studied in our module 1 only, and recently also we have taken this. Okay, so now it is required to use this one because this is a surface. Now if you see diagrammatically, you assume this is now x direction, this is y, this is z. So wave is propagating in the x direction. Wave is propagating in the x direction, but how the plane is there? They have given plane equation is 2x plus y is equal to 5. Here people will get lot of confusion. So see carefully, 2x plus y is equal to y. It is actually, by seeing this one, people will tell it is a line equation. But as a EMT student, you should say here Z content is not there. So Z value you have to take from minus infinity to plus infinity. So it is a directly line, but for all the values of Z, if you consider, it is plane only. It is a plane. How this plane is there? For example, if you think it is x, it is y. On x-axis, it will be available for y is equal to 0. If you take y is equal to 0, x is equal to 5 by 2. Is 5 by 2. If you take y is x is 0, you will get y is equal to 5. So one line is passing through these 2 points. Another line, that means z is coming outside. So for all the values of z, that means so infinite number of lines, line by line, line by line, line by line will create a surface, will create the plane. So this is the plane, not surface now. It is the plane. That plane will be available like this. That is the plane we have here. That is 2x plus y is equal to y. So plane direction is this one, but wave direction is this one. So both are not same. So carefully we have to calculate our power, average power formula. It is equal to surface integral of power density into ds n cap. So it is equal to simply we can take here what is the 81 milliwatts per meter square. This is in x direction. ds what is the surface here we got 10 power minus, otherwise ds only you write now. And what is the n cap direction? 2x cap plus y cap. Z is not available. Y square root of 4 plus 1. 2 square plus 1 is 5. So it is equal to power is having only x component, but surface is having x component and y component. So dot product between x and y is 0. So you will be having a product of only x components only. So 81 milli I'm writing outside, 2 by root 5 also I'm writing outside. So x cap dot x cap is 1. So integral s ds. So what is the total surface? They have given 10 power minus 2 meters square. So 81 meters into, sorry, 81 milli into 2 by root 5 into what is the total surface? 10 power minus 2. This will give your power propagating through that particular given surface. Okay. So how much you will get means 724, writing here 724 microwatts. This is the answer. So it is very good problem. Lot of some knowledge is required in order to do this problem, not only Poynting theorem concept. So simply I will revise this one once again. See carefully. Good problem. This is a very good problem. Problem is basically available on the Poynting theorem concept. So you need to know the formulas for these two. Okay, formulas for these two. But in order to calculate the power density, you require here eta, but they did not give eta. To get eta, you require epsilon r. Epsilon r also they did not give. For that, we use it the velocity concept, omega b beta, and we have taken this one. We have equated to root of mu epsilon. So this one you should know. This one you should know. Then you have calculated a epsilon r value. Then you have calculated this eta. Then you have calculated average power density. Then you have calculated average power. But in the calculation of average power also, it is not straightforward. Okay, power is propagating like this, but surface is available like this in a different direction. Okay, that is this direction. So n cap you have calculated. For that we used ax cap plus by cap plus cz cap by square root of ax square, a square plus b square plus z square. That concept is required. So if you know all these things, then only you can solve this particular problem. Okay, so everything is important. So carefully you have to understand all these things. Okay, so if you have any doubt in this one, you can ask me now. Concept of the Poynting theorem and the problem, whatever we have done. And I will give one homework problem also. If you have any doubt, you can ask me now. Hello. Hello.
No doubt, sir.
Okay. Then you take one problem, write down all of you. In free space, I will write in the next slide otherwise. All of you write down. In free space, h bar is equal to, they have given h bar here. H bar is equal to 0.2 cos of omega t minus beta x x cap amps per meter. Find the total power passing through. Find total power passing through. Total power passing through a bit. Square plate of square plate of 10 centimeters on plane x plus z is equal to 1 and b bit. That is one surface. That is square surface. That means what is the area? 10 centimeters means 100 centimeters square. Okay, that is the area they have given. Next question, next BBT is a circular disc. A circular disc of radius 5 centimeters on plane x is equal to 1. This is what they have given. Okay. So you can calculate the things now. Here 2 times you have to calculate. 2 problems are there here. Next, a circular disc means you can take a pi r square as the area. So 5 into this 5 square into 5 into 5. 5 square, but you need to convert everything into meters. Okay. This is the thing. And answers also I will give. Okay, you can do in the next class, we'll see about this. Okay. So it's already 10:40. I'm closing the session. If you have any doubts, you can ask. Otherwise, I will close the session. Is it okay?
So direction of wave,
Direction of wave?
direction of propagation, next cap, sir.
Okay, okay. Here we will change that one otherwise. Find two, it is not electromagnetic wave because direction of propagation is x and h bar is also oriented in the x cap only. So we'll change this one. You assume direction of the orientation of h bar is we can take z cap. Now both are different, so it is a proper electromagnetic wave only. Is it okay? Hello?
Yes, sir.
Okay. So I'm closing the session. Practice this one. This topic is important for the examination and not only for the examination, for the gate exam also we have several problems based on this one. Okay. Okay, I'm closing this one.